Dear students, in our previous presentation related to the HVDC and HVAC comparison, we have made the comparison based on certain aspects like economics, then technical parameters, reliability, and other things, right? So they are specific, comparisons. So with this presentation, I will try to make the comparison more generalized, right? So I will make it more generalized, and for this particular comparison I have taken certain pics from the internet, courtesy to internet, and accordingly we will see how exactly we should be able to have the comparison between the AC and DC high voltage transmission systems. Okay, so now if you look at this particular diagram, maybe this is quite self-explanatory after having gone through the previous presentation which I did earlier, right? So one thing is that the HVDC is cheaper than HVAC for the long distance, right? So now if you look at the two diagrams here, right? One related to the terminal cost as well as the line cost, right? What I mean by the terminal cost is the terminal equipments which are required to be present on either side of your transmission line, and the other one is the line cost. Okay, so now if you look at the line cost of the DC and the line cost of the AC, definitely after certain distance, okay, after certain distance, your line cost DC will appear to be beneficial compared to the line cost of the AC. So similarly, if you make the comparison between the terminal cost of the DC with respect to the terminal cost of the AC, definitely the terminal cost of the DC is more compared to the terminal cost of the AC. This is a very important point to be noted, because on either side you will have to have very highly rated and very highly sophisticated controllers which are acting as either the rectifier or the inverter, and along with that you may have so many other auxiliary circuits as per the requirement of the controllers, especially when you have high power transmission of the or high voltage transmission of the power. Okay, so therefore you can, if you look at the line cost of the DC and AC, there is a break-even distance, right, over which your DC system appears to be more beneficial economically compared to the AC system. Generally, this break-even distance, may be somewhere around 500 kilometer as per the thumb rules or the experimental values which we have considered from the various case studies and all, right? So in this way, when you compare the HVAC system with the HVDC system, definitely the HVDC system appears to be cheaper than the HVAC system for the long distance, especially when the distance is above, say, 500 kilometer or more. Okay, this is one important point to be noted. Then if you look at one more parameter for the comparison, I am trying to generalize these things, right? So now the distance as well as the amount of power determines the choice of the DC over AC. So this is another point which is which is related to what we have said in the previous slide, right? The distance as well as the amount of power, right? So if you look at the second diagram here, right, you can see here the x-axis represents the megawatt and y-axis represents the relative cost with respect to megawatt. Now a single conductor HVDC system will be definitely always beneficial compared to a three conductor HVAC system, and sometimes you may have the bipolar link also, wherein you will be having the two conductors here. That time also probably this line may come somewhere here, right? So that means your HVDC system is definitely less cost effective related to cost per megawatt with respect to megawatt if you take, right, in comparison HVAC system. What you can see here, that is just because you make use of more conductors in a AC system compared to the DC system for the same amount of power to be transmitted. This is another thing to be kept in mind. So the distance as well as the amount of power, right, it determines the choice between the DC systems, right? Then again on the same grounds, let us try to see the one more point of comparison. You can see here the direct current conserves forest and saves the land, right? So now if you look at the two pics of the two corridors which are used for an HVAC system and HVDC system, right? So one is the 400 kilo which is HVAC, but a higher voltage system in HVDC. You can see here the transmission corridor, a typical case it is, right? For a 500 kilovolt HVDC system is somewhere around 46 meter, whereas the 400 kilovolt HVAC system has transmission corridor width of almost double the HVDC system. So now when the corridor itself is so wide, definitely the associated costs, the tower size, right, the height of the tower, all those things will be definitely going to be more in comparison with that of the HVDC system. That means the towers of the DC lines are narrower, simpler and cheaper compared to the towers of the AC line. So that means if you make the comparison between these two, definitely this is going to be the choice as long as the tower size and the associated costs are concerned. So another the general point which is required to be considered here. Next, the same thing is represented by means of some of the pics that I have taken from the internet. So now you have a look over the AC transmission line corridor, right? And maybe a similarly rated the DC line corridor is represented something like this. You can see here, you can see, right, the width of the transmission corridor, right, and the nature of the simple in comparison with the nature of the towers which are used in the AC transmission system. So in this way you can have savings in the forest cuttings or the deforestation, whatever you can call, as long as the systems are concerned. So that you can see in this diagram. Okay, so since the corridor is narrower, definitely there will be less deforestation and all, as long as a new HVDC system comes into picture for the realization, right? So now if you look at the next point, right, if you look here, lesser corona loss compared to the HVAC system, right? We are speaking about the different corona effects now, but the very corona effect transmission and distribution system you have studied, right? So this basically is because of the spacing, the voltage gradients, right? So or the charging current which is responsible for the ionization of the air between the two conductors, right? So all these problems are more in the AC system compared to the DC system, right? That means the corona losses are less in DC systems compared to the AC system. Then one more important thing to be noted here is the direction of the power flow can be changed very quickly. So because complete control here is as per the operation of the two converters on either side. So you know that the converter, by making use of the converter, the direction of the power flow can be easily reversed by having the proper control over the triggering angle or the delay we call, right? So now as long as the value of alpha is less than 90 degree, you know that it acts as the rectifier in a three-phase converter system. Once it exceeds till 180 degree, you will be able to operate the controller in the inversion mode, right? So this is relatively simple in the DC transmission system. So therefore, wherever there is a requirement to change the direction of the power flow quickly, then definitely your DC systems are more advantageous compared to the AC systems. Then one more thing is that the HVDC has greater reliability, right? And a bipolar DC is more reliable than a three-phase HVAC system. DC requires less insulation. We have already seen this in our actual presentations on the comparison, right? And this is again seen here. An optimized DC link has a smaller towers than the optimized AC link of equal capacity that we have seen in our previous slide, right? So now if you look at this, the DC in parallel with the AC link. You can always have a DC line in parallel with the AC link existing system, so that you can have a lot of savings in terms of the uh, auxiliary infrastructure that you need to provide, right? Now, if you look at the losses with respect to the transmission distance, right? So now there is a break-even point here, right? So now your HVAC is HVDC is this, and the HVAC is this. Beyond this, definitely the losses are more in the DC system compared to AC system compared to the DC system. So up to certain dips in the DC system are more because of the terminal equipment losses or the power losses that are taking place in the terminal equipments. But once the distance exceeds certain value, say which I have earlier referred to it as 500 kilometer or something like that, right? So then definitely the overall power losses associated with the DC transmission system are much less than that of the AC transmission system when you go beyond certain distance. And if you keep increasing the distance, definitely the amount of the losses are going to be more and more in a AC system of the equally rated capacity with respect to a DC system. Okay, so these are some of the important aspects that we have generalized here based on whatever we have discussed in our previous presentation. Now let me put up all these things in the uh, form of a summary here, right? Let us now confine discussion to HVDC only, HVDC in comparison with the HVAC. What are the limitations? Okay. Now the first one here, the greater power per conductor. This is already seen, right? So because the HVDC system employs either two conductors or a single conductor in comparison with the HVAC system. Then simple line construction, no need to have the explanation on this again, right? Ground return can be used in the HVDC system, right? Each conductor can be operated as an independent circuit because of the ground return. This is one important advantage. Then you don't have the problems related to the charging currents, your corona effect or the amount of the insulation to be provided. All those things can be avoided, right? Higher insulation and other things. Then you don't have the skin effect here in the HVDC system. And nowadays the cable manufacturing technology has gone to that extent that they are designed to work with a very high voltage, right? So this is one advantage of the cables, where these cables are deployed in your HVDC system, right? So the line power factor is always unity, right? So the line does not require reactive power compensation. However, the reactive power compensation or the reactive power requirement can be seen in the converters, right? Less corona loss, less radio interference, especially in foul weather for a certain conductor diameter and RMS voltage, right? Whenever the weather conditions are not good, when the system is operated in the extreme conditions, so these are going to be really beneficial, right? Then the synchronous operation is not required because your frequency does not come into picture at all, right? So it will always operate at a DC level. So once the synchronous operation is not required, so it is not possible for us to, necessary for us to link the stability of the system with the distance. Whereas in an AC system, the stability of the system greatly depends upon the distance, where as the distance increases, you have got a lot of variations in the voltage levels. Okay, so that problem doesn't arise here. May interconnect AC systems of different frequencies. Basically, this point we have not yet discussed. Anyway, I will come up with these things in our subsequent presentation. These are called as BTB, back-to-back HVDC systems, right? How exactly this back-to-back HVDC systems can be used to interconnect AC systems of different frequencies, that we shall see later. Low short circuit current on the DC line and does
the uh, the power electronic devices or the converters which are being used there. So These are some of the important advantages which are summarized based on whatever we have discussed earlier, right? And that doesn't mean that your HVDC system is always advantageous over the HVAC system. This particular point I have made very clear. Whenever we discuss about a particular system, we will always try to give the more positives of that particular system with respect to its other counterparts, right? So now let us see some of the limitations as well. As long as the HVDC system is concerned, they are referred to as the disadvantages here, right? And in comparison with the same amount of power to be transmitted, right? So whatever the HVAC system and HVDC system, if you have, right, the converter in the HVDC systems are definitely very expensive, and the operation is also quite complicated, right? Because it has to have the conversion of the power, or the conversion of the power from AC to DC and DC to AC on a large scale. A large quantity of the power has to be converted. So principally it may be very simple, but when you really implement these things, you need to have a lot of issues to be addressed here. Maybe these things we shall see in our discussions on the controllers, right? So the second drawback here is the converters require higher amount of the reactive power. This I've already told you. So the converters generate harmonics and require filters, and these are the general problems related to any kind of the converters, right? So they require the reactive power, they generate the harmonics, they need the filters. These are the general issues related with the converters. But these issues can be really complicated when the converters are very high. This is the very important point to be noted. And the converter have little overload capability. This is another issue which is to be addressed with respect to HVDC system. And the last one here, the HVDC circuit breakers, right? So the circuit breakers are normally very well operated in the AC system, because you have the natural zero crossing of the voltage or current, right? You can make breaker to get opened at the natural zero. So but in the DC, that too when a large amount of current is flowing, right, you have to sub the current to zero when it has got a very large quantity, and accordingly to open the contacts. So this becomes really troublesome and difficult. So therefore the realization of the DC circuit breakers will be much difficult compared to the realization of the AC circuit breaker. So this is going to be another bottleneck, and this has to be addressed in a special manner, right? So the requirement of the HVDC circuit breakers. Now these are some of the disadvantages or limitations as long as the HVDC systems are concerned, right? In our next presentation, right, we shall see what are the basic components in a HVDC system. So how exactly they are materialized, and what is the function of each block in the HVDC system. Okay, we will stop here.